So this lesson is going to be on electricity and magnetism. When it comes to electricity on the G test, it'll probably be what we call electrical circuits. So you have this power source, in this case, a battery, and then you'll have these wires moving around, and then you'll have some type of work being done. In this case, it'd be a light bulb, and then the wire would have to make its way back to the power source. So without all this being connected, no work can be done. Uh, the circuit would be unable to function. So if you're missing a wire, or if this is not connected correctly, if the power source is missing, the electrical circuit will not work. Something that's kind of cool is when you think of this battery, notice there's a positive charge and negative charge, but what's really happening with batteries when there's this chemical reaction, what's actually traveling through the wire is actually what we call a negative charge. In other words, electrons are being traveling through the wires, and then they're able to make contact and conduct electricity, which will then actually turn on the light bulb and create light, if you will. And then the electrons will go ahead and pass back into the power source. So as long as the circuit is all connected, there will be light. But if anything is disconnected, there will no longer be a true path for the electricity to travel. Electricity needs what they call a closed circuit. If anything gets opened up, then the electricity will not travel. So that's important about electricity. So the other thing we want to talk about are magnetism. You know, with our Earth, there is this North Pole and South Pole, and what's really cool is they create this magnetic force, this magnetic field that protects us from solar radiation. For us, for the GD test, you know, we're going to deal with something a little bit more simple. You know, more as a kid, you played with magnets. There's on a magnet, there's a North Pole and a South Pole. And what's cool with the magnets, though, is if you have opposite poles pointing to each other, in other words, if you have a North Pole on one side and a South Pole, if they're the closest to each other, the magnets will actually pull together and snap together. So when they're opposite poles here, the magnets will actually attract each other. They will come together. So this is what this is kind of trying to show you, that these magnets are actually coming together. Now, if one magnet has the North Pole and the other magnet has North Pole facing each other, if they have the same poles facing each other, what's actually happening is if you try to push these magnets together, you may notice that they won't actually try to push together. They'll actually push away from each other. That pushing away, a lot of times they'll use that word repel. So they won't attract. The opposite of attract is repel. They'll go move away. You may have heard like insect repellent. You're trying to repel insects from you, making them go away from you. So if the poles are the same, the magnets will actually move away from each other or repel. And that's the same way with the south poles. If you're pointing the magnets with both south poles facing each other, the magnets will not attract each other. They will actually repel each other. And that's a quick lesson then on electricity and magnetism. Electricity is going to be about this circuit, and magnets is going to be about this attraction and repelling.